Hello
Hello.
everyone, this is actually my second take on this. I actually recorded this whole video and then I found out there was an overlay of audio. So this is my second time. I'll try making it quick and brief. Let's see how well I can do. We're talking about soil, everyone. Welcome to it. I hope you are excited just as much as I am. Jokes aside, soil, what we're going to talk about is actually super quite important. It's one of the biggest things that, as environmental science teacher as well as environmental scientist, we just don't hear about or talk about enough. So you're going to kind of get an update on that today, and we're going to kind of briefly talk about the main system of soil, and we'll kind of talk about the inputs, outputs of soil, but we'll go into more detail about the importance of soil in future lectures. So stay with me. You will understand by the end of this lecture, at least I hope, by the end of Unit 5, that how important soil is and why it deserves its absolute own unit in our environmental science class. Okay, to kind of start off, we're talking about systems today, all about systems. So when we're kind of viewing this, think about those complex systems that we've talked about before, and now thinking about soil and systems. Soils are major components of the world's ecosystems. Obviously, I think you guys kind of know that about soil, right? Without soil, we probably wouldn't have the plants or life that we have. It's important for the whole process of photosynthesis to take nutrients out of the ground from the soil, and it goes into our food or plants, and then breaks down and continues the cycle. Soils are a part of the atmosphere, lithosphere, biosphere, and hydrosphere. Soil really encompasses all of those within it. As we're going to talk about the makeup of soil, it takes from each of those. It interacts with each of them in its own complex way or in specific ways, which makes soil kind of special. So kind of example, water cycle. Obviously, water flows through soil as well as evaporates from soil. We have atmosphere. We have gases that go in and out of soil from the atmosphere, which are a part of the soil. Rocks, part of the lithosphere, break down and they go into the soil and make up what the composition of the soil actually is. And then we have part of the biosphere. We have tons of living, billions upon billions of things living in the soil. And, that's how plants are able to live. They take nutrients from the soil. So do understand that, right? We're going to talk greatly in detail on why soils are important to humans. But here's just a brief couple outline of what we'll eventually kind of talk about. But they're a medium for growth, right? We grow our food on soil. We need good quality soil to grow the food on this planet for us. Soil stores our fresh water. 0.005% of all fresh water exists or is stored in soil. And it's the water that a lot of us rely upon for drinking. Soil filters water. It cleans it. It makes it drinkable for us. It recycles nutrients, takes place in the soil. Dead organic material is broken down through transformations, and then it's broken down into simpler components, which then are recycled through other plants as well as other living beings. Soil is the habitat for billions of microorganisms. I think I already said that, but tons. Think of worms, bugs, even larger creatures live in the soil. And then soil provides raw materials, peat, clay, sands, gravel, and minerals that we utilize for construction. Think of anything that's made of concrete. It comes from the soil or is important for soil. Starting out here, just know that soil it's a very slow process. It takes years and years and years for nice, good quality soil to form. You can go talk to Miss Catherine, who has the compost heap outside. She's making soil. It takes a long time for things to break down and turn into good usable dirt. It takes, because the processes are mechanical, such as weathering of rock, deposition of sediments by erosion, which is also mechanical, and we have deposition of organic matter, so chemical breakdown of organic matter that then goes into soil and forms the composition of soil. This little graphic, we're going to get into this quite a bit, especially in this lecture. We're going to be talking about these horizons right here. Just know, next couple slides actually we'll be talking about it. But it's just a beautiful graphic to kind of really show you the makeup of all the things that possibly could go into soil. So if you do have time, pause it here and just kind of look at these different types of soil and what type of things make up soil. All right, but moving along, we're going to talk about soil horizons, which is right here. Now, do know that I have two different kind of lists. We're going to kind of focus on the 5-layer system. Just know in this graphic, it does show the E horizon, which is, it's dependent on the type of area you're in. Not all soils will have the E horizon, so we're kind of focus on these 5. But just know in the graphic that it depends on what soil we're talking about and who you're talking to, what layers there might be. Okay, but we'll kind of briefly stick on these. But first off is the O horizon. Think about going into a jungle or a forest. You're stepping through the brush, you hear the crunch of the leaves or the wood. That is the O horizon. All that organic decaying material that is on the very surface. It's this very tiny, tiny little area. That is, or sometimes it can be thicker, right? Depending on the area. But that's the O horizon, all organic material. The next layer down is what we usually think of when we think of dirt. This is the surface soil where plants and trees utilize and take up nutrients from. But this is a nice kind of the horizon that really has a mixture of organic as well as mineral type of deposits, right? We have, you have breaking down of rock, which then, gives you iron, clay, calcium, or then also the organic compounds. So this is just kind of the nice area where you think of the typical dirt that you might pull out of the ground. Going down past that is the B horizon, which is the subsoil. Excuse me. The B horizon, really how it changes is it's much like the A horizon, but it's getting more minerally, right? Think about layering. Usually the heavier things kind of sink to the bottom first. So the B horizon just is an area that has more maybe clay or mineral type of sand, like maybe not sand, but maybe bigger type of mineral rock formations that kind of fall down because of due to being heavier. And it just keeps going there. C horizon even more so. C horizon contains just bigger pieces of rock, more of the heavier things that kind of sink to the bottom. And then finally, we have R, which is the bedrock, bedrock is nothing really gets past this point. Think of just a solid piece of rock. No soil really gets, or water kind of gets past this point. This is kind of the part of the Earth's surface that just allows no passage through leaching. And no matter where you're at on the planet, you're eventually going to hit bedrock, or this layer that just won't allow passage of these natural things such as organic or smaller pieces of rock through it, just because it's solid, right? And to kind of continue on that, it's important to know that this isn't standard throughout wherever you go on the planet. Some have very thin horizons. It might be just a foot, and then you hit bedrock. Other areas you might go, several hundred meters before you eventually get to bedrock. Usually that's kind of extreme, but it's a possibility. So just know it's different for the area you're at. And this just kind of breaks it down a little bit more, so I won't go through it again, but it just kind of breaks it into a more simplified version for you. Okay, with this slide, it's really important to know that soil contains all 3 states of matter. We have gases, we have liquids, and we have solids in soil. We have air, water, minerals, organic material, humus, roots, organisms. All these things are what actually make up soil. So we often think of just the solid material, such as the broken down rock, organic material, but just know that air is greatly involved in soil. Roughly, through this graph, depending on, once again, the type of soil, but sometimes up to 25% of the soil is made up of gases. 25% of it is water or moisture, and then kind of the 50% is those solid materials. So do know that it's this nice makeup of these different type of particles and different types of states of matter that exist within soil. Now this kind of gets into the part where, thinking about soil as a system. Once again, we know obviously you're all intelligent people. You know that systems include inputs, outputs, stores, and flows of different things that go within a system, right? Soil is no different. Soil has inputs, which we'll talk about. Stuff that goes into the soil that makes the soil. Then we have outputs, things that leave the soil and eventually go to a different area. We have translocations, which are just mainly, the moving of different particles from one place to another. We have transformations, which is a flow, but like think about the broken down organic material that breaks down, it changes into something else and goes into the soil. Right? And there's two really driving forces for these processes. Just know that it depends on what type of soil you have. Not all soil is standard. Often when we think of soil, we think of that dark, rich, brownish black stuff that we can hold in our hands, and it has moisture, and we can grow plants in it. Just know that not all soil is like that. If you were to go into northern Thailand and go through the jungle, or maybe central Thailand, you would see that the soil is kind of reddish. Or if you go to a different area, it might be more sandy or more clay-like or more muddy. There's many different types of soil, and really what that depends on is the climate above it. Is it, what's the temperature above it? How much precipitation does it get? And that then changes the organisms that live upon it, right? Up here, and then they break down and they really kind of form what type of soil you'll get. That dark, rich soil that we often think about is a perfect mixture of mineral, organic material, and moisture, as well as gases, right? If you're getting a redder soil or a more sandy soil, obviously there's probably, red soil, you can get a lot of organic material, but it leaches through it, and we'll kind of talk about that later on in the unit. So it really depends on what type of soil you have on your feet, and it's not all uniform throughout the planet. And it depends on really the two driving factors are temperature and precipitation. Then that changes what grows on it, and the topography, and then that changes what type of soil you'll get. Okay. Speaking on this, so we're going to talk about just briefly about some of the inputs, right? We have mainly three inputs or three input types: weathering, atmospheric inputs, and biological inputs. We'll kind of break them down into each, but just know these are things that go into the soil that are adding to it, right? So weathering, rock breaks down through erosional processes, through wind or rain. Rock will eventually break down more and more and more and go into the soil. And then just also remember from earth science that there's different types of rocks, right? There's igneous, metamorphic, sedimentary rock, and all those different components. Some have more calcium, some have more sodium, silicon, iron, aluminum. So you have a definite mixture of those rocks breaking down and going into the soil, which affects the soil. Atmospheric inputs. These are things like carbon and nitrogen, and as well as organic materials, because of their particulates in the atmosphere. So think of all the things in the air eventually kind of lay down on the soil, and they get mixed within the soil as well. So those are inputs that eventually go into it. And then we have, which we've kind of already talked about, but the biological, right? The things living upon the soil that then eventually die, get broken down, and then are put into the soil, such as nitrogen, and carbon that comes from living life, that breaks down and goes into it, right? Okay, outputs. Obviously, things leave soil, right? The big, the one I didn't add here is, which I'll talk about briefly, is outputs. You would kind of put plants, right? Let's say there's a tree on the soil. Well, that tree is taking up nutrients or taking things out of that soil. So that would technically be an output as well. Then we have erosional processes, which I have here, but think about, rain or, wind that picks up soil, or, there's runoff on the surface of the soil, which then transports it out to the ocean or picks it up through the wind and puts it into the atmosphere. So there's erosional processes that take away soil. We have leaching, which is rain that then seeps down into the ground. Well, that rain that seeps into the ground is called leaching, and then it takes things with it, like organic compounds or smaller particles, and then it leaches all the way to the bottom. This is big in kind of tropical environments. That's why Thailand doesn't have the greatest soil, or at least around Bangkok it does, because of all the nutrients. But if you go into the mountains or the rainforest, it's a redder soil. You would think, well, shouldn't it have beautiful organic material? No, because there's so much rain that organic material gets washed away or seeps through the soil and then funnels down to, which we are lucky to live in Bangkok, which is the Chao Phraya River, then moves it out here. That is why Bangkok is here technically, right? It has all that beautiful soil from the mountain ranges and the tropical rainforest, which then is funneled down here, so we get the benefit of all that leaching. And then gaseous losses, right? And just as gases can go in the soil, they can also evaporate or leave the soil. So this is, nitrogen is a big one on this. When it can go into the ground, and it can eventually leave as well through just due to the nature of gases, right? The gases include energy, so they tend to be lighter, and then they can leave the soil as well. Okay. This is just a quick slide on transformation. So I want to talk about, we're talking about flows, right? You have two different types of flows, and hopefully you remember this from the very first unit, right? We have transfers, which, a thing stays the same and is just moved from one location to the next. Then we have a transformation, which one particle then changes into something else and goes through the process. Just know that, soil systems have that too. We have organic material that, let's say a poor animal dies on the soil. It doesn't, seep through as that animal. It breaks down into its basic components of carbon and nitrogen and different types of fertilizers. It breaks down. That's a transformation process, and it leaches through and mixes with the soil. And this is just kind of to get you thinking about, the different types of stores, transfers, inputs, outputs, and transformations in soil. And I think I already kind of spoke on these, but this is just kind of a nice, handy table for you to kind of look at, and will help you kind of guide you in your thinking. And finally, ladies and gentlemen, this is just a systems diagram of what's happening in soil. Now, this is not complete. There could be many more pieces to this. Depending on the soil, it might look greatly different. But just do know that, soil is this big systematic complex, right? This system of many things working together that make up soil. There's living things in it. There's dead things in it. There's rock. There's gases. There's liquids in it. So do know that this, and when you're drawing out this system, which you will do in your part 1 of the workbook, you have to draw out a system. You can make it look very much like this, but I would like you to take time and think about possible other types of scenarios, right? Maybe add slightly different things to your diagram when you're writing it in there, and just a reminder that you'll have to take a photo of it and then send that as a separate document to me when you're turning in your workbook part 1. But do know that not all dirt, not all soil is the same. There could be many different inputs or outputs or flows happening depending on the temperature and water that flows through it, right? So do know that when you're constructing yours, and have fun with it. And maybe it doesn't have to be as intense as this, but close. To really deeply think about many of the things you often don't think about as inputs, outputs, flows of a soil system. Okay. All right. That is my second time. Look at it. I wrapped it up in about 18 minutes. Please take care, everyone. Until part 2, we will continue to have fun. Trust me, soil will get more interesting. We just have to kind of break down the set pieces of what makes soil. All right. Talk to you soon. Bye.